Ecology of Kamiak Butte by Caroline Bertoli, SOE 300, Fall 2019. Along the border between Washington, Oregon, and Idaho, fissures whose length ranged from tens to hundreds of kilometers in length experienced highly effusive eruptions of flood basalts. These lava flows began about 17 million years ago and didn't stop until about 6 million years ago. Although continental crust is more buoyant than oceanic crust, the flood basalts were miles thick, and that much new material piled on top of the crust pressed it down slightly. Today, the Columbia River Basalt Group is the youngest and smallest case of flood basalts on Earth. Kamiak Butte is among the few areas that have peaks exposed above the thick layers of hardened basalt. Weathering and erosion of the basalt eventually began to form soil. Flooding. Next in the series of geologic events that shaped the Pacific Northwest as we know it was a sequence of massive floods. A period of glaciation caused colossal ice dams, such as in Lake Missoula in Montana, behind which massive quantities of water were stored. As the Earth gradually warmed and cooled in its usual patterns respectively, the floods would break forth with more force than all of the rivers on the planet, and then the dams would reset. This cycle continued for at least 25 floods, carving out the channeled scablands of Idaho, Washington, and Oregon. Water from the cataclysmic floods eroded loose cover of the Palouse and made channels that exposed the underlying basalt. Plateaus and canyons are characteristic of the scablands with butte and basin typography. For the most part, the floodwaters stripped bare these areas of soil and the loess that so defines the Palouse. It scattered debris and erratics that are significant to the current landscape. Glacial erratics are boulders that are an unusual size and shape compared to their surroundings, because ice can move the largest and most poorly sorted rocks and debris. Glaciers are one method of weathering, which is the catalyst for soil formation. Soil composition. When the scablands were stripped of their soil and assorted debris, erratics deposited at the Wallula Gap formed a dam. The soil and debris that was washed away from the scablands was then built up behind the dam as the water filtered through the boulders, but the organic material was held behind. The loess that fell over the Palouse made for extremely rich and productive farmland, which explains why our beloved Washington State University is surrounded by wheat fields and farm animals. However, Kamiak Butte is particularly productive due to the quartzite foundation that managed to peak above the basalt covering the rest of the Palouse. Flora and fauna thrive on the butte with high biodiversity and primary productivity. The Palouse is a unique landscape in terms of its geologic life story and typography. All of the geologic events the area has experienced have added up in perfect sequence to form the lush landscape we know today. Air masses. Kamiak Butte has a unique climate that makes it a good representation of the way the biosphere and atmosphere interact. The air masses over Kamiak Butte have strong impact on the climate there. Specifically, Washington State is dominated by polar air masses. On one side, a marine polar air mass originating from the Pacific moves inland westward. On the other side, a continental polar air mass originating in Canada moves south over the region. Marine polar air masses are cool and moist, considering that they are formed over water on higher latitudes. They are not as cold as Arctic air masses, but they are colder than tropical air masses. Continental air masses are cold and dry, containing far less moisture than their marine counterparts due to their origin over land. The Cascade Mountain Range generally blocks marine polar air masses, making eastern Washington much drier than western Washington. Rain shadow effect. The Cascade Mountain Range also contributes to the case of rain shadow effect that is prevalent between western and eastern Washington. Clouds form from the condensation of evaporated water vapor over bodies of water such as the Pacific. As clouds travel inland toward the eastern part of the state, changes in elevation affect how much water vapor they can carry. In order to pass over increased elevation, such as the Cascade Range, they have to release some of their water to be light enough to move up and over. This is because the humid air rises by orographic lifting. Therefore, the side of the mountain that the clouds release their rain on, called the windward side, has a very wet climate compared to the side they descend on, called the leeward side. In the case of Kamiak Butte, its location on the eastern side of the state makes it cool and dry for most of the year. Continentality and typography. Overall, climate of Kamiak Butte is best described by examining the mesoclimate. Mesoclimate describes the smallest area between mesoclimate, macroclimate, and megaclimate. Mesoclimate is specific to a subregion, whereas others describe the climate of a broad-scale region within a continent, and that common to several different continents, respectively. Continentality refers to how much an area is affected by oceans or large land masses. Since Kamiak Butte is located on the interior of the state, it would experience higher continentality. Land masses have a much lower heat capacity than water bodies, making the region of Kamiak Butte have an overall colder climate. Additionally, the high latitude of Washington would also contribute to cooler temperatures. In terms of typography, the physical features of the region that contribute the most to the climate of Kamiak Butte include the Cascade Range. Kamiak Butte would be located on the leeward side, causing it to be generally dry. Site 1, Northern Aspect. After visiting 2 different sites on the Butte and recording data about the organisms living there, we were able to observe the environment in action. Site 1 was located on the north-facing aspect of the Butte and was relatively lush. We conducted our data collection at coordinates north 46, west 117, and an elevation of 3,044 feet. Being from the western side of Washington, I personally could not endorse this site as the most dense and green forest I have seen. However, it displayed a stark contrast to the second site. Due to the shade and plenty of rainfall on this side of Kamiak Butte, we observed the biodiversity and species richness that the area had to offer. Vegetation here resembled that of higher mountain elevations, with a thick layering of understory, midstory, and overstory. 3 main species were observable in the overstory: ponderosa pine, Douglas fir, and western larch. By observing the distribution and counting the exact number of each species with a 9-meter radius, we determined that each of these tall tree species had dispersed distribution and no evidence of regeneration. There were no saplings within sight, which is reasonable considering the rapidly approaching winter. We counted 3 ponderosa pines, 4 Douglas fir trees, and a single western larch within our data collection site. Based on these data, we were able to calculate the number of trees per acre, which were 48, 64, and 16, respectively. The midstory mainly showed 2 species of shrub, ninebark and ocean spray. Ocean spray we observed to be a taller shrub, contributing around 40% of the canopy coverage, while ninebark is a short shrub, contributing the other 60%. Ocean spray was dispersed, whereas ninebark was patchy, and neither demonstrated signs of regeneration. Orchard grass, an annual grass, dominated the understory completely. Full layering of the canopies heavily juxtaposed what we then found on the south-facing aspect of Kamiak Butte. Site 2, Southern Aspect. Site 2 was located on the south-facing aspect of Kamiak Butte and displayed far less greenery than the north side, although the view allowed by the lack of trees is spectacular. The end of the basalt flows is clearly visible at the end of the tree line. At this site, our data collection radius was 12 meters at 3,209 feet of elevation. Out of ponderosa pine, Douglas fir, and western larch, we were only able to find the first species of tree in our site. Furthermore, we only counted 3 specimens. Extrapolated to trees per acre, this calculated out to only 48. As for the mid-story, we observed a variety of shrubs including bitter cherry, arrowleaf, and serviceberry. Some shrubs showed signs of herbivory from deers and rabbits, and we observed a porcupine nest in a nearby tree. Within our data collection radius, there were few shrubs. The understory was dominated by Idaho fescue and annual grass. Anthropogenic landscapes. Anthropogenic landscapes can be defined as areas where direct human alteration of ecological patterns and processes is significant, ongoing, and directed toward servicing the needs of human populations for food, shelter, and other resources and services including recreation and aesthetic needs. In the case of Kamiak Butte, extensive industrial agriculture and extensive pastoral landscapes characterized by low population density but intense agriculture and livestock raising have overtaken the Palouse. The lush soils are extremely appealing to farmers. Not only do they facilitate lush native growth like the trees, shrubs, and grasses found on Kamiak Butte, crops such as wheat, wine grapes, and barley find the soils particularly plentiful as well. Additionally, the Palouse is the largest lentil exporting region in the United States. The agriculture industry in Washington state is worth $6.4 billion and has accelerated erosion of the Palouse soils to unprecedented levels. Mechanization causing increased erosion rates, as well as irrigation redirecting water, has harmful effects on the landscape, including Kamiak Butte, as the primary producers are negatively impacted by soil erosion that provides their nutrients and redirection of water to agriculture. Every trophic level and individual organism in the region's complex food web is affected. References.